Today I have sent the your MS1 to the school. So I have leave it with the guardhouse. Can you hear me or not? Someone please on the mic. Can you hear me well?
Yes.
Okay, thank you. Okay. Then so next week you can hand in your MS2 lah, but not after Friday, before Friday, please. So Friday I will go and collect the MS2. Okay. So when you tell your parents to hand in your MS2 times, then tell them to collect back your MS1 lah. Okay. So it's with the school guard lah, huh? Okay. So now. Okay, we continue. Okay, we finish that day until 3.2. So if you have your textbook, turn to page 88. Okay, can see the screen? Can see the textbook?
Yes.
Okay, come. So let us start today's lesson. Okay, so this is too big. Okay. Okay, so you write today index, indefinite integral, okay, for this. Okay, this is today index. Today is 12. Okay, use MX3. Okay, so today what are we going to learn how to integrate this ax plus b and then in bracket power n. Okay, so okay, we go through this. Earlier we have studied how to integrate the functions such as y equals to 2x plus 1. Okay, integrate 2x plus 1. We revise a little bit. Okay, integrate this. Okay, so you just write back the 2. Okay, increase the power. So 1 plus 1 is 2. Remember, over 2, over the new power. Okay, and then plus. Okay, this is how to say, constant. Okay, so the integration for a constant, you will get that constant times x. So 1 times x, you get x. Okay, so remember plus c. Okay, this one simplify. Therefore, the answer is x squared plus x plus c. Okay, so revision a little bit. Okay, then we continue. How do we find the integral for the function of this? You see, power 8. Oh, power 8. If you want to expand it, it's very difficult. Okay, the expansion for this, okay, the power 8 is difficult to expand. Sorry, the expressions for this. Since functions like this will request us to use a substitution methods. Okay, so this one, after these explanations, it just explain for the formula. Okay, how you get the formula. I don't think is how to say, you're going to use this method to get the answer I mean for this substitution method. So at the end you have the formula already. We're going to just use the formula, okay, to get the integration in this form. Okay, integration in this form with the power n. Okay, so let us start. Okay, so let's set this integration is equal to y. Okay, so this one means actually, okay, you have learned this. What is y? Y actually is the integration of the dy dx with respect to x. Okay, I repeat, what is y? Y is the integration of dy dx with respect to x. Okay, this is the definition for the y. Okay, so now you compare with this. You compare with this. So you will see actually this I can write it equal to this. Okay, therefore, I have this. Okay, dy dx is equal to ax plus b, the whole thing power n. Okay, so for substitution method, I'm going to substitute this function, okay, with u. I'm going to substitute this one with u. Okay, after that, using chain rule to get the answer. Okay, so when I substitute this one with u, so I have a u equals to ax plus b. Then I immediately from here I want to find du dx. Okay, this one to get ready for my chain rule. Okay, so du dx, differentiate this with respect to x, I get a. Okay, then dy dx. Okay, I can write my dy dx now with, instead of this, because I have replaced the ax plus b with u, so I write it as u to power n. Okay, so now by using chain rule, okay, dy du. Okay, so I write dy here, I write du here. The other variable is x, so dx and dx here. Okay, so what is dy dx? What is dy dx? Dy dx is here. Okay, what is dx du? I don't have dx du, but I have du dx is here. Okay, so I write it as terbalik, okay, inverted it. Okay, so dx du as 1 over du dx. Okay, sorry, dx du is 1 over du dx. Okay, therefore it's 1 over a here. Okay, so it replaces 1 over a, and then dy dx replaced with u to power n. Okay, so I have this. Okay, then continue. Okay, for you to find y. Okay, what's the purpose for me? What is the purpose for these questions? I want to find y. Okay, I want to find y because I want to find the integration of this so it means I want to find y. Okay, for me, want to find y for here. Okay, I'm going to write in this way. Y is equal to integration of this with respect to u. Like, you know, this u du move to this side. Okay, and then do integration. Okay, so how to get y is by integrate this with respect to u. Okay, so we continue. Okay, we can do the integration with respect to u already. It's because I got no functions here. Okay, I assume the u as a variable. Okay, although actually u is a function lah. Okay, but this in this integration, I will just assume this u as a variable. Okay, so how to integrate u to power n? Okay, so very simple. Okay, you just drag out the 1 over a. Okay, integrate u to power n is u, okay, the power plus 1, so n plus 1. Okay, then over, remember the new power n plus 1. Okay, this is what you get. Okay, then remember plus c. Okay, so this is what you get. That just substitute back. Okay, just substitute back. What is y? Okay, just now, what is y? What is y? Okay, y we have earlier we set as is an integration for x plus b power n. Okay, with respect to x. So now I write back what is y as this integration of ax plus b. Okay, the whole thing power n dx. Okay, then this one I get this. Okay, last step ready. Just substitute back the u. Okay, become ax plus b. Okay, substitute back the u, become ax plus b. This is why you get this formula. Okay, you get this formula. Okay, so after this, okay, you're not going to go through the step just now. Okay, the substitution method. You just use this formula. Okay, so after I will practice with you how to use this formula. Okay, to get the integration of this. Okay, so okay, the expressions, okay, for this can be expanded by using binomial theorem. Again, okay, I remember that day Dashna asked me, okay, to revise with you the binomial theorem. You remember the triangle, okay, the binomial expansion for the triangle one, okay, start with 1 and then 1, 1, you still remember the number, okay, but here they are talking about binomial theorem, okay, but you see the binomial theorem they involved with this one you didn't learn yet. Okay, the C stand for combination that you're going to learn very soon. I think two more chapters or what. Okay. When you learn permutation and combination, this is under statistic. Okay, so C stand for the combination. Okay, so that's why I don't want to teach you in this way. I teach you in the triangle way. Okay, but both are the same thing. Okay, if you have this already, you know how to do the combination already, then you don't have to depend on the triangle already. Okay, but because you didn't learn this yet, so I don't want to introduce to you this one yet, so I introduce to you the triangle lah. For you, for those who want to use a binomial expansion for expand the expressions, and then only do the differentiation or the integration, then you use this the triangle methods. Okay, then we look at this. Okay, using the formula on the left, can you find the integral of this? Anyone? I only have 10 minutes. Anyone? Okay, I go back to the questions. Anyone want to try? Yes or no? Come, anyone want to try? Do you think using just now that formula, okay, can solve for this integral or not? I'm not sure who is here. Maybe Siranya, want to try? Siranya here or not here? Yeah, yeah, Siranya, are you here? Uh, uh. Oh, okay. How about Shahira? Shahira here, right? Okay. You got no mic Someone got mic easier. Shahira got mic or not? Mm-hmm. Okay Janelle. No mic Okay, Janelle. Oh,
Yes,
Janelle.
teacher.
Here, come. You got mic. Very good. Answer my questions, Okay, look at this. What do you think? You think the formula just now, okay, can find the integral of this or not?
Yes.
Yes, sir. Mm. The answer is no lah.
Oh, okay.
um, okay, never mind. The answer is no, but can someone explain to me why the answer is no? Okay, I don't know who else got mine. Uh, Sarah, maybe. Sarah got mine, Sarah?
Yes,
Very good.
teacher.
Alright, come. Okay, they are just now that formula actually cannot solve for this, cannot find the integral of this. Can you tell me the reason?
I think you need to expand first
Yeah, you need to expand to solve it. Okay, but can you tell me why just now that formula cannot use to solve this?
because the substitute only can be for linear.
Substitute only can
Not
collinear.
not
What's
linear.
not linear, you mean? You mean the inside here, this function 3x squared plus 3 is not a linear function, correct or not? Do you mean that?
Yes.
Oh, your mic also very blur. Okay, let us see. Okay, we see back, we look at this formula again. You see there's inside the bracket, this is ax plus b without any power. That's why Sarah just now said this is linear. Okay, means the x here is power 1, linear. Okay, while you compare with this, this is power 2. So remember that now, just now that formula only can be used for, okay, ax plus b. Okay, inside this bracket is linear only. Okay, not linear, you cannot use that formula. In fact, not linear, and then with a big power, okay, if you can't expand it, actually no way for you to do for integration. Okay, a very, very big power, let's say 10 lah, 11 lah, or whatever lah. Okay, power 3 is still okay. You still can expand and then integrate it term by term, but not using the formula just now. Okay, so I will give you a few examples. Okay, how to use the formula just now. Okay, we look at this. Okay, power 5. Okay, so how to use a formula just now? I'm not going to use this method. I'm not going to use this method. I will just straight away use the formula. Okay, apply the formula. Okay, so very fast. Okay, you just copy back the bracket. Copy back the bracket. Okay, and then the power plus 1. Okay, do like a normal integration. Power plus 1. So 5 plus 1 is 6. Okay, over the 6, the new power. Okay, after that, remember, okay, here you need to denominator time with the a. Ax plus b, so a is this. So times with 3. Okay, that's all. Plus c. Okay, so you just write back nicely. So it's a 3x plus 5 power 6. Okay, 6 times 3, 18 plus c. Okay, finish. Okay, so I'm going to repeat again. Okay, for this, you're going to write, okay, power half. Okay, power half. Okay, actually, you see just now, they say here, okay, n is an integer. N means the power. This one is not necessary. Okay, because of this example already show that. Okay, you see the power here is not an integer, half is not an integer. Okay, so we do the same thing, don't worry. Okay, copy the bracket. Okay, the power, remember, plus 1. Okay, so it's 3 over 2. Okay, over, copy back the new power, remember, times with the a here is 5 plus c. Okay, then just rearrange back. This is 15. Okay, 15 over 2, the 2 bring up here, so become 2 over 15. 5x plus 2, okay, power 3 over 2 plus c. Okay, so this is how I get the answer. Do a few more. Okay, 2 more here. Okay, so how about this? Okay, integrate this. Integrate this. Okay, same thing. So copy back the bracket. Okay, the power plus 1. 4 plus 1 is 5 over 5 times with the a. Okay, remember the a is the coefficient for the x. So the a now is -3, not 2. Not 2. Okay, so it's -3 plus c. Okay, then we rearrange a bit. Okay, so here is a negative. I put a negative at the side, and 15. Okay, plus c. Okay, so I get the answer. Okay, one more. X. Okay, so this one I'm going to put the 3 outside. Okay, then 5x minus 3. Okay, the power, because it's at the denominator, I'm going to write it as a -6. Okay, dx. Okay, now I integrate this. Okay, so 5x minus 3. Okay, the power plus 1. So -6 plus 1 is -5. okay, over -5, the new power, times the A. A here is 5. Okay, plus C. Okay, so I rearrange. This is negative 3 over 25. And then denominator, I bring this down to denominator, power 5 plus C. Okay, so correct. Okay, tepat. So that's all for today. Okay, we just do one exercise. Better than nothing, actually. I can finish one exercise. I'm very happy already. Okay, so you just do this exercise for today. Okay, wait for a while. Stop record.